In the movie Lord of the Rings Return of the King, Sauron's army of orcs uses a battering ram to break down the gates of Minas Tirith.
The way a battering ram works is almost identical to the way that a pendulum works, especially in terms of the law of conservation of energy.
Cool.
If Grond was hung from 20 meters and weighs 1,000 kilograms and was pulled up at an angle of 50 degrees, use this information to solve the following two questions. Part A. If Grond is released at 50 degrees, what is its velocity when it hits the gate?
Part B. How much force is applied when Grond hits the gate? Alright, so for part A, you're trying to find the velocity of Grond at this point. So to do that, you need to find out what the kinetic energy is at that point by using this equation, K equals 1/2 mv squared. Now the most important thing about how the battering ram works is it's almost identical to the way the pendulum works. The whole thing is about law of conservation of energy. The total amount of energy at every position the battering ram is at, the total energy is equal to the sum of the potential and kinetic energy. The difference is how much is potential and how much is kinetic at every position. The easy part about this is when it's at rest right here, all of it is kinetic energy, and therefore when it's up here at its max height, all of it is potential energy. Now, the equation for potential energy is U equals mgh. And that's what we need to figure out first, because the potential energy right here is equal to the kinetic energy right here. It's the conservation of energy. So, to figure out potential energy, we already have mass, and we know what gravity is. The only thing left is the delta H, which is this area. This right here we can figure out by just using a simple trig problem. So that will be, let's see, 20 cosine of 50 degrees, and that is...
That was 12.85, Nick.
Alright, 12.85, thank you, Chris. And therefore, delta H is 20 minus 12.85, which equals 7.15. Am I right, Chris?
That you are, Nick. That you are.
Brother. So, now you can find potential energy. Just plug it all in. Plug it into 1,000 kilograms, 9.8 for gravity, 7.15 for the delta H. What's that, Chris?
70,070.
Alright, so that's 70 joules, as you can see right down here. When it's pulled up, right up here, the energy is 70,070 joules, which means that when it's right here, the kinetic energy is the exact same thing. Now, it's really easy. All that's left to do, Plug it in for this. And then when you rearrange that, all you have left is something pretty simple. Alright, Chris, what's that?
That was 11.83 meters per second.
Alright. And there you have it, folks. When Grand is right there and it hits the gate of Minas Tirith, it is moving at 11.83 meters per second. Gotta love it.
So now you need to find out how much force Grand exerted on the gate. Well, that's very easy. We solve for energy, which is just another word for work. So, work equals 70,070 joules. Alright, now, what can you do? You gotta remember your equations. Work equals force times distance. Now, you know work, you're trying to solve for force. What can you do? Solve for distance. How? Your little trig functions once again. Just take the cosine of 50 times 20, and that comes out to be... What was that, Nick?
That comes out to be... I'm sorry, Chris. Let's see, that comes out to be about 15.3 meters.
15.3 meters, alright. So, we have the D, 15.3. Now, just rearrange your equation. Into work divided by distance equals force. So, 770 joules divided by 15.3 meters equals, what was that, Nick?
That was about 4,574 newtons, Chris.
Say that one more time? That's a big number.
4,574 newtons.
And there you go. Simple as pie.
And so, according to the math and according to the logic, you can see why Grand is the most perfect battering ram ever designed, or certainly close to it.